Hello everyone, welcome back. In last video we have seen the network and network review. Now we will see how to use network trace. So let's start. Go to the network trace and first option will be find connected. Okay, by using this you will find the any point connections by choosing any point. Okay, if I suppose I choose the OST and click on that, so it will select all the elements connected to the this point. For example, if there is another zone or another network in the same scenario, and if you want to find connected, click on that. So you will get the whole network by clicking on the single point. Okay, it will get easier when you working on the multiple zones in the same network. So this function is used for that purpose. Next is find adjacent nodes. Click on that. Okay, if you want to find adjacent node of this point, okay, click on the point. After that, find adjacent node. It will select all the nodes adjacent to the this point. Then we have find adjacent links. So we have selected 3 points. Click on the adjacent link. It will select all the links connected to the 3 points. Okay, then again find adjacent nodes. It will choose all the nodes connected to the pipe. So it is very helpful tool. Then we have find adjacent start node. Okay, if I select this point and click on start node, it will show only start node of the uh, adjacent pipe or nodes. So these are the start nodes of the pipe. If you click on that, you will find that J146 is the start node. Then again we have the find stop node. Okay, this is the pipe you have selected and find the stop node. The stop node is 213. If you click on that and find stop node, you will get these 2 points are the stop nodes of the this point. Okay, then we have the associated customer consumer meters. Then again these are the consumer meters. It is helpful for the SCADA element, not useful for us. Find disconnected. Okay, if you want to find disconnected joins or points, you can find by using that. The find connected and find disconnected are quite same. You won't find in much of difference. You can use one of the two, so it won't be any changes. Then customer meters not connected to the nearest link. These are helpful when you use customer meter. So in our case we didn't use any customer meter, so it won't be relevant. Then find reverse lateral. So when you use lateral pipes, this query will be helpful to find out the reverse lateral pipes. When we work on the network, many pipes would get reversed. Okay, so it will helpful only for the laterals, not the all the pipes. Then find the shortest path. If you want to find shortest path between these any 2 points, it will give you that. For example, I select first point this and stop point will be OST. Okay, first start and stop point and click on OK. It will give you the smallest path. This is the uh, branch network, so there is only one single line. When you connect it to the multiple lines, or we can say the loop network, it is very difficult to find out the shortest path. So by using this method or this tool, you can find the shortest path. Okay, here you can see this network is connected in the loop. If you want to find the shortest path, again click on the first junction, then click on the second junction. There is two path, but it will select only the shortest path. You will see the path will change from this point to J761 and going around from this to 213 point junction. But this route will be long compared to the selected one, so it will choose the short one. Okay, then we have trace upstream. If you want to know the upstream pipes, click on tape trace upstream and click on the any downstream pipe. For example, J61, click on that and it will give you the uh, path to path towards the OST. These are two different option: find shortest path and trace upstream. These are two different tools. Find shortest path use 2 points to find the small path, but trace upstream always go to the upstream point or OST point. Okay, then trace downstream, it is the same, but it will go to the downstream. If you want to find the network of your zone, click on the any OST or any point you want to find out, click on the point and click on OK. So you will get the all the zones, command area or zones under the junction. Like click on the point. So these are the points or pipeline are commanded by the 209 junction. Okay, for this purpose trace downstream command are used. Then we have part to the nearest element or specific type. So these are the same like find shortest path. Okay, but it only uses the elements over here. If I choose tank and junction, it will give you the shortest path. These are the same find shortest path and find the nearest element, quite the same option. Then we have nearest upstream and downstream. These are all the same option with slightly different function. Then we have isolate, element to isolate. Click on that. You will find this is also same as the find connected. It will find the isolated junction or any connected pipes. It will select all the network. If I click on that, it will select all the network. So these are the network trace. You can use it while your network is too big. Then we have the input. These two options are not that useful as network trace, but still some tools we can still use it, like duplicate labels. If you have duplicate labels, then it will get highlighted like P10, P10, P9. Here you can see P13, P8 are repeated. So all the repeated labels will be highlighted. Then we have inactive elements. When you use active topology, it will be helpful for that purpose. Then all the elements are not that relevant to normal distribution. It will helpful for file flows or leak detections. These are options for those purpose. Same as the result, when you have negative pressures you want to find, then we have empty tank, full tank. These are the option where you can use in EPS method. Okay, now main we have the query of custom query. how we can create custom query by using the option. Okay, here you will see first option is query hydraulic model. Click on that, right click and new, create new query on if you want to create on pipes, click on pipes or any junction tank, whatever you want to choose. Click on pipe, this window will pop up. So suppose I want to create query on head loss gradient. Okay, choose head loss gradient here. Where is head loss gradient? Okay, here you will see head loss gradient meter per kilometer. Double click on that. I want to make sure that all the pipes are less pipes head loss gradient should be less than 4 meter per kilometer. So head loss gradient less than 4. Okay, then click on the compute button. 183 of 217 elements were found. Okay, that means our formula is correct. Click on yes. Pipe query, these are the custom query. Now we will create it head loss. I will rename it HGL or HLG. Okay, if you click on that, all the pipe will be selected uh, which have more than 3 head loss gradient. We will see. So this pipe should be have more than 3 head loss gradient. Head loss gradient meter per kilometer. Okay, head loss gradient is 0.017. It means something went wrong with the formula, because with the small amount of head loss gradient it will still fall under the query. We have to find the error. So we will see different one. Head loss gradient still lower than the 3. Okay, we put wrong formula in the box. We want all the pipes greater than 4. So we need all the head loss gradient pipe should be greater than 4, then it will be selected. Click on OK. Now click on that again. Okay. So you will see these pipe are selected. We will see if head loss gradient is greater than 4. Head loss gradient is 321, which is more than 4. That's why these pipes are selected. We will check another query on the junction. So I will choose junction, click on OK, and I suppose choose demand. I want to choose demand which is less than 0. So if suppose any uh, demand of junction is not consider or put 0, so it will be selected in demand query. Okay, so if I click on demand, it will show, it will not select any junctions, which means we don't have any junctions with 0 demand. We can check it by click on the junction. Now you will see this is the demand center and data collection demand is 0, but still is not in the query. It means again we have to change the formula. So we want to select all the junctions with 0 demand. Okay, so we will write the formula like demand which is less than and equal to 0, then it will be selected. So I choose again, click on the demand. So we will run query again, click on demand. You will see all the demands are highlighted where demand is 0. You can see 0 item. Here you will see 0. There is demand, but other selected junctions have the 0 demand. There is still demand, but it's showing 0. So all the junction are selected by using this query. So something like that you can uh, create custom query. I have already created like velocity which is greater than 1.8 meter per second. You will see these pipe have higher velocity than the query. Then we have again Hyzen-Williams. We have head loss gradient and velocity less than 0.1. So these are the queries you can create by using custom queries and make your network more efficient and cost effective. Thank you for watching, guys. If you have any queries about the topic, you can ask me through my LinkedIn account or just comment below. Thank you.